Hey everybody, today we're going to do a little lesson with piecewise functions, but now we're going to work backwards. We're actually going to take a graph and we're going to write the equation. So this is going to be challenging in some ways. So what we're going to do is we're going to do the best we can to make it as easy as possible for you. A lot of times you can do this graphically, a lot of times you're going to have to do it algebraically. So you're going to see it done in a variety of ways during this lesson. So here we go. First thing says represent an absolute value function. Now we want to write it as a piecewise function. So the first thing you have to do is think about what does an absolute value function look like? Well, here's the absolute value of x, but if we think about it graphically, we know the standard absolute value graph looks like this. We have our vertex at the origin, and to the right we go up, and to the left we go up. But let's think about that in terms of slope. If we look at the left side, the slope of the line is actually a -1 because we're going down from left to right. If we look at the right side, the slope is going up, so it's a +1. So we need to keep that in mind when we write our absolute value function. So the absolute value function can be written as a piecewise function, and it's going to look a little something like this. We have two parts to the graph. Okay, the part to the left is a negative slope, so we have -x as our equation, and that's only true when x is less than or equal to 0 or less than 0 for now. I'm just going to write less than just for a second. To the right, the graph is going up. It has a positive slope, so it's just x. Okay, and this is only when x is greater than or equal to 0. Now the thing is we only need to have one of them be greater than or equal to, so it really doesn't matter. So you just have to pick one, so that way you have a solid dot and you don't have another solid dot sitting on top. Doesn't really matter, no, but this is just proper. Okay, doing it from a graph. Graph B here, we have three parts. We have a blue part, a green part, and a red part. So to start off, we're just going to take our absolute value. We're going to just say f of x is equal to, and we're going to make one of these because we've got three pieces, you see. We've got a blue piece, we've got a green piece, and we have a red piece. Now sometimes it's easier to just start with your domain. So if you look at just the blue piece, that's only when x is less than or equal to -6. See, because here's a solid dot, so we're going to include the -6, and it's only going to the left. So this is when x is less than or equal to a -6. For the green part of the graph, you see we have two open circles. It goes from -6 to -1. So for the green part of the graph, we're just going to be from -6 is less than x, which is less than a -1. And then finally the red part, as you see, we have an arrow at the end, so he's going to go into infinity. So the red part is just when x is greater than or equal to, notice the solid dot, -1. And now we have to go back and we have to actually get the equations of these three pieces. Now that can sometimes be tricky. Part B, it's not that bad because you can follow the slope here. So look, we can just follow the slope. It's going down 3 over 2. We can go down 3 over 2, down 3 over 2, down 3 over 2, and we can find our y-intercept is -7. Okay, so our slope is down 3 over 2. So for this, it's -3/2 x minus 7. Okay, and then you just want to get rid of this blue line we just drew. We don't need it. It's not part of the graph. Remember, we want it to be a function. That's just how you can use the current slope of this blue line to get the y-intercept. Okay? There is another way we can do it, and you'll see that in the next example. Here is our green line. It's a horizontal line at -3, so it's just -3. From -6 to -1, and you're done. The last part, though, this is absolute value. And you've got to go back and think of absolute value. We have a couple things that we need to find. First of all, we've got our absolute value. Our vertex, you can see, is at 5, -2. So remember, 5, -2 is opposite of the inside, outside. So this is actually x minus 5 minus 2. And now you still have to look at the slope. the slope is down 2 over 3. So there's your absolute value part of this graph. So you have all three parts to the graph now, and that's how you write an absolute value equation from a graph. Okay? So you might want to rewind that, go back and check out any steps that you missed. Part C does have a tricky part to the graph because we can't find the y-intercept easily for the green line here. What I'm going to ask you to do anyway is I'm going to ask you to pause the video and try part C for a minute or two on your own and see how much you can get. Okay, so let's see if you did this correctly. First, we got the blue line. Now again, we can see that we have a slope that goes up 4 over 3. We can go up 4 over 3, and you lucked out, you get the y-intercept. So this one, you've got a slope of positive 4/3. X, you have a y-intercept, or a b, of 2. And this is when x is less than -3. Notice we have the open circle. So this is when x is less than a -3. Okay, we get rid of our little line we created. And the green part is where things get tricky. So if you look, the green goes from -3 to 5. They are included. And for now, we're just going to skip to the easy part for just a second. This is a horizontal line. For the red, it's when x, we have an open circle, so x is greater than 5. And that's just a horizontal line at y equals 6. So let's talk about the green part, because that's the tricky part here. We don't know where it crosses the y-axis. So what you're going to need to do is you're actually going to have to use some writing equations of line skills. Now we're going to pretend that this is supposed to be exactly on the coordinate -3, 2. This is supposed to be at 5, 4. So we're going to actually use those points. And we could also just use the slope by counting. You can go up 2 and you can go over 8. Okay, so you can go up 2 over 8. So this is just one of those things where you're going to have to use some writing equation skills. So how about point slope form? Y minus y1 is equal to the slope we just found is up 2 over 8, which is 1/4. And then we have x minus x1, and you just get to pick one of those points. So pick any point that you want. I'm just going to pick the 5, 4. So we're just going to do y minus 4 is equal to 1/4 times x minus 5. And then we just need to write the equation. We just distribute the 1/4, so this is 1/4 x minus 5/4. Add the 4 to both sides, which is, if you want to see it, 16/4. So that's how we're going to end up with 1/4 x plus -5/4, and 16/4 is 11/4. Okay, so that sometimes is the tricky part, is you might actually have to use some writing equations of line skills from the previous chapter, or the previous section in this chapter, to be able to find a part of our piecewise function. Okay, so that's that for doing it with a graph. The next thing we're going to do is do it for word problems. So you are actually going to write piecewise functions from word problems. So number 2. Number 2, it doesn't tell you what variables to use, so if you like f of x or y is equal to, and then we can use x, that's fine. So this one says shipping costs $6 on purchases of up to $50, $8 on purchases over $50 to $100, and $10 on purchases from $100 to $200. So we're going to write the function. Now these are just horizontal lines because it's just based on the shipping costs, okay? So our shipping costs are going to be 6 when x is from 0 to $50. Notice we include the 50, not the 0, because, well, they're not going to charge you for buying nothing. That'd be crazy. You'd be getting bills all the time for, hey, you bought nothing from us, here's your $6 shipping. I don't think so. Then it's $8 for purchases over 50 but up to 100. So that means it does not include 50 this time, but it goes all the way up to 100. And then finally, it's going to be $10 for purchases of more than 100 all the way up to $200. Okay, so there's your function. That one's pretty easy to write because we don't have to find any slope, any equation, with like point slope form or anything. We're just read the problem, write what it says. Then it says we have to state the domain and range. Now remember, domain is your x values. So your domain is, here's some notation for you. Your domain is going to be for x, and that's when 0 is less than x, which is less than or equal to $200. Okay? So that's domain. Domain is, you're not going to spend $0 or negative dollars. So anything more than 0 up to $200 represents the domain of this problem. It didn't say it had to be 50, 100, and 200. You can spend $57. You can spend $123 if you want to. But the range, think about the range. The range is when y is equal to 6, 8, or $10. Okay, that's it. If your item costs $57, you're going to pay $6 in shipping. If your item cost, or I'm sorry, 57 would be $8. If your item costs $150, you're going to pay $10 in shipping. It's not like it's an increment per dollar. It's for a certain group. Okay, so your shipping costs are only going to be $6, $8, or $10. Okay, so problem number 3, this is where we're going to have a lot of fun. Okay, this question actually takes quite a bit of work. So, a plane descends from 5,000 feet at 250 feet per minute for 6 minutes. So we're going to start by writing altitude is equal to, and then we're going to be working in terms of time. The first part says for 6 minutes. So the first part of this is going to be 0 is less than t, which is less than or equal to 6 minutes. So what is this equation? How can we represent that? We're going down at 250 feet per minute, so 250 t plus the original altitude of 5,000. Okay, not bad. So this is going to bring us to, and you need to calculate this, if you go down at 250 feet for 6 minutes with an original altitude of 5,000, that's going to leave you at 3,500 feet. Now that coordinate is 6, 3,500. Do not confuse that with a starting point of 3,500 for the second part. So what we need to do is we need to read the next part. For the next 8 minutes, so from 6 to 14 minutes, we have a new slope of negative 150 feet per minute plus, now the 3,500 does not go there. That's not this. This is 6, 3,500, not 0, 3,500. So again, we had some technical difficulties there. I hope you can still hear me. So we have y minus 3,500 is equal to our slope of negative 150 times x minus 6. And we just have to work that out, and we're actually going to find that our y-intercept. Okay, I hope you can hear me because we've had some technical difficulties here, and it kept on telling me that it was paused and it couldn't hear the microphone. What you need to do is you need to use this coordinate at y minus 3,500 is equal to your negative 150 times x minus 6, and you have to find your y-intercept. Okay, you need to find b. So once you do that, you're going to find out that y is equal to negative 150 x plus 4,400. And that's going to be your b. So this 4,400 goes there, not the 3,500, because 3,500 is after 6 minutes. You have to go back and find 0. Okay, so that's piecewise functions from a graph and from a word problem. Go back, watch this if you need to. Otherwise, you know where to find me tomorrow. Have a good one, and this is Longo, and I'm out.